In this session, I'll give a live demo on external incompressible CFD analysis of Fuselage by using SimScale software. SimScale software is a cloud software. To access SimScale software, search for the web address simscale.com in the browser. Next, go to Dashboard, create a new project, give project title, describe your project, and choose the category. I'll give the project title as Fuselage. Describe it as external CFD analysis. Choose category as aerospace and click on create project. Next, to import geometry required for the analysis, go to Geometries, click on the plus icon in Geometries, import geometry from the computer and click on Import. The fuselage geometry is imported. Next, to create domain, we will use enclosure function. For that, right click on fuselage, go to add geometry operation. Here you have the enclosure function. Here you need to enter the dimensions of your domain or enclosure. I will enter the domain dimensions here. Domain is created for our fuselage geometry. Select translucent surfaces with wireframe. You can have a look. Domain created around the fuselage. Next, hide the domain. Select active box selection. Select the fuselage. In the scene tree, in topological entity set, click on the plus icon and name this entity. I will name it as fuselage CAD mode and click on create new set. Right click, show all. With this, the pre-processing step completes And the next step is solver execution step. To start with the solver execution step, go to simulations, click on the plus icon in simulations, select incompressible and click on create simulation. I will keep the same K omega SST as turbulence model and time dependency as steady state. Save it. Next, assign materials. Select air, apply. Kinematic viscosity, I will enter 1.5 e power minus 5 meters square per second, and density, I'll give it 1.19 kg per meter cube. So these kinematic viscosity and density values are for the altitude of 300 meter. Save it. Next, in initial conditions, I'll keep the same default value. Next, we will apply the boundary conditions. First, select velocity inlet. Here you need to input the inlet velocity and select the inlet phase of your domain. I'll give the inlet velocity as minus 90 meter per second. Here in this problem, the air is flowing along Z axis. The air enters through this space and flows along the negative axis of Z and exit through this space. Therefore, the inlet velocity will be negative for this problem. Select the inlet phase and save it. Next, add pressure outlet. Here I'll give the gauge pressure and select the outlet phase and save it. Next, apply wall boundary condition. In velocity, I'll select moving wall. Give velocity same which you gave at the velocity inlet as minus 90 meter per second. So this is the moving wall. Save it. Next, apply wall boundary conditions and now select slip wall. Select the free surfaces of your domain. And save it. In advanced concepts, in numerics, I'll keep the same default values and same for the simulation control. Next, we will assign the result control, add forces and movements. Here you need to enter the CG of your geometry. I'll enter the CG values. And in the scene tree, select the fuselage CAD mode under topological entity set. And save it. Next, add forces and movement coefficients. In forces and movement coefficient, enter your CG values again. The lift is along y-axis, so Iy will be 1, remaining 0, 0. Drag is along z-axis, along negative of z-axis, so minus 1, remaining will be 0, 0. And pitch is along x-axis, so it will be x is 1, remaining y and z will remain 0, 0. And the free stream velocity which I gave was 90 meter per second, and the reference length of the fuselage is and the area. Assign the phase here. Assign fuselage CAD mode under topological entity set and save it. So we are done with result control. The next step is mesh. To generate mesh, click on mesh and generate. Mesh is generated over the domain and the geometry. After the mesh is generated, the next step is to run the simulation. Click on simulation run and start. The simulation is completed. This completes the solver execution step. Next, we shall move to the post-processing step, where we'll be analyzing the results which are got after simulation. To view the lift, drag, lift coefficient and drag coefficient values, go to force plot, forces and movements. The pressure force X is the drag force and the pressure force Y is the lift force. Accept those two. Disable the other options. Pressure force X or drag value is this, and pressure force Y is 234.14 Newton. Next, we shall see the values of lift coefficient and drag coefficients. This is the lift coefficient and drag coefficient. In this way, you can analyze the values of lift and drag forces, lift coefficient and drag coefficient. Next, to analyze the velocity magnitude counter plot and pressure counter plot, click on post-process results. In parts color, select pressure. Hide the domain. This is the pressure counter plot of the fuselage. Next, to see the velocity magnitude counter plot, add cutting plane. I'll give orientation as X. Hide the domain. Disable parts color. This is the velocity magnitude counter plot of the fuselage. Let's analyze the streamlines over the fuselage. Add particle trace. Disable cutting plane. Click here. I'll increase the horizontal and vertical seats to 15. Hide the domain. In parts color, select solid color. You can see the streamlines over the fuselage surface. You can also animate the streamlines. For that, add animation, select particle trace, increase the speed, and click. With this, I will end up this session here. Thank you.